Hi, this is JNGL, and today we are going to be looking at Unit 3, new unit, standards 3.1 to 3.2, and we have some new theorems, and this whole unit is about triangles. And I have not made a video in quite a while, actually about a week, because if you saw the other video, there was like some tornadoes that came through Little Rock, but that was no problem. I was actually just sick for the last few days, so that's why I've not made one in a few days. So I have a lot of other makeup work for my classes that I take this year, so I was not able to make my own notes, but I was able to find some online. And here they are. So it already has everything written down, but first we have the triangle sum theorem. And if you don't remember what a theorem is, just look at the other video, 2 point, maybe it was 1.4, I don't remember, but there's one. But this is the sum of the measures of the angles of a triangle is 180 degrees. So the measures of all three angles will equal 180 degrees. So obviously you could find x if we are given 35 and 65. We know that them added together, which is 100, 180 minus 100 would give us x. Or you could just do 35 plus 65 plus x equals 180. And then from here, for this one, you would have to know your straight angles rule, which is that they'll add up to equal 180. So x and y would equal 180. That's how you would figure that out. Trying to move kind of fast for this one. I'll be able to go into more depth with this one, which I'll do in the next video. So this is classifying triangles by their angles. So these are the ways that you classify them. You might have learned about this in maybe 7th grade or 5th grade or something like that, but here's the different things that you have. So I really don't like to say some of these words because they don't come out so good for me. But I'm not going to really say this word because I know that if I said it, it would not be so good. So you see that? That means that all of the angles are congruent. Remember, the congruent symbol is the equal signs with the tilde on top. So if they're all equal, then it is. And if all of them are acute, which means less than 90 degrees, that means that it is an acute triangle. If one of them is a right angle, then it is a right triangle. And if one of them is obtuse, then it's obtuse triangle. You might say, what if there's more than one right angle or obtuse? Well, sorry about that. That's not possible because think about it. Like, if you had 3 right angles, all the sides wouldn't connect and it wouldn't be a triangle. So that wouldn't work. And then classifying them by their sides is equilateral, is if all sides are congruent, and isosceles is if 2 sides are congruent, and scalene is if no sides are congruent. So already we have the answers here, but from this one you can tell this is obtuse and scalene. Well, first, from the angles, we can tell that it's obtuse because of this 110. And then we can tell it's scalene because 4, 6, and 11 are not equal. So we know that that's what that is. For this one, acute, all of these measures are less than 90, so that would make it acute. And then once again, it's scalene because 2, 3, and 4 are not equal. Now for this one, we have all less than 90 degrees, so it's acute again. And then it's also isosceles because we have two measures that are the same, the 12ths, but the 8 is different. That's why it's not a right triangle. Or sorry, not a right triangle, equilateral. So down here, apparently whoever made this messed up. It's not cute. So it is that because they're all the same, all 60. And then equilateral because all of these are equal. Okay, I mean, I guess I could try to say it, but I just stop. I'm not gonna say that. I can't. All right, and then so it's right angle because we see this right angle right here, and then it's scalene because all of them are different. But we can find out that this would work for the Pythagorean theorem, which is on the next video because we have this this Pythagorean triple, which you'll learn about. That's what the 3, 4, 5 is. Okay, here's one thing. All right, find the ratio of 3 angles in a triangle that is 2, 6, 8 ratio. So that might seem like, what the heck is that, really? Well, whenever you have something like that, all it will mean is that you just add x's to them and they go as the measures. So 2x, 8x, 6x. There you go. And from that, you can solve. You set them equal to 180 because remember back up here, we know that them added equals 180. So then you solve and you get x equals 1125. But you might want to know if you wanted to find the measures, then you just plug x in, and that's what you did. And it would be the same thing for that one. So then we have the remote interior angles and exterior angles. So here's the theorem for this. The measure of each exterior angle, which is the one that's like pointing out, of a triangle equals the sum of the measures of its two remote interior angles. So what it means is that the exterior will equal the sum of the two remote interiors. That's all that means. So from here we can tell that 130 would equal 70 plus x because that's what we know. And same thing for this one, you would solve like that. If you really need the example, you can just pause the video when I'm up here to see how the work was done. But like I said, I have a whole lot to do and I really don't have a whole lot of time for this video. But when I get to some of the other ones, I will explain in more depth. Alright, now properties of isosceles and equilateral triangles. Well, here's the isosceles triangle theorem. If two sides of a triangle are congruent, then the opposite angles are also. So these are what the opposite angles would be, these two blue marks. And then these are the equal sides. And then the converse, remember that's just like the opposite thing, so you switch that up. So knowing both of these, it goes both ways. So yeah. And then the theorem, another theorem that we have is the bisector of the vertex angle of an isosceles triangle is a perpendicular bisector of the base. If you don't remember what that is, that's the thing that separates the two segments pieces, and it means that it will make them equal. So right here, they're equal. That's all that means. And then let's see. Corollary. This is a statement that follows immediately from a theorem. So it's like, all right, well you have that theorem. Oh, the corollary. That there you go. That now you know that's gonna happen. So here's one that's of an isosceles triangle theorem. If a triangle is an equilateral, then it is blank. That word. Okay, so what does that really mean? Okay, well, we know that what that would mean, and so then we know that's what happens. So if it's that, then it's that. That's all that means. So really what that means is if we find out that, what am I trying to say? if we find out that if we go back up here to the definitions of those, this word right here is if all the sides are equal. So if we know that all the sides are equal, if we know all the angles are equal, then all the sides are also. So that's what we know. If we know that all of the sides are equal, then we know that also all of the angles are. So these sides are equal, then all these are, and if all three sides of a triangle are equal, they always have to add up to 180. So if they're all equal, well, what thing can times 3 into 180? So you basically would just divide and find out that they're all 60. And then you also have the converse, which is if a triangle is that, then it is also that. So we find out that all of the angles are equal, so we know all these are. So we have to know that x and y are 10 also. And then a regular triangle is just a triangle that is both equilateral and blank. And, well, here's some practice. I mean, you already see the answers, but you can pause the video and try to see what the answers are here. And that is it. Thank you for watching this video, and stay tuned to watch